The minimum clearance between secondary conductors and communication lines spanning between two utility poles is 6 feet. This clearance is crucial for safety and to prevent accidental contact between the power and communication systems. Conversely, maintaining adequate separation minimizes the risk of electrical hazards such as arcing or short circuits that could occur if the lines were to come into close proximity due to wind, ice loading, or other environmental factors. Secondly, sufficient clearance ensures that communication workers can safely access and maintain their lines without the danger of contacting energized conductors. This separation is not arbitrary, it is based on established safety standards and regulations designed to protect both the public and utility personnel. The National Electrical Safety Code, or NESC, provides detailed guidelines on clearances for various voltage levels and conductor configurations. These guidelines take into account factors such as voltage, sag, and sway of the conductors. In addition to the 6-foot minimum, there may be other factors that influence the required clearance in specific situations. For example, if the secondary conductors carry higher voltages, the required clearance may be greater. Similarly, if the communication lines are carrying sensitive data or equipment, additional separation may be necessary to prevent interference or damage from the electrical field. Proper installation and maintenance are essential to ensure that the required clearances are maintained throughout the lifespan of the utility lines. This includes regular inspections to identify and address any sagging conductors, leaning poles, or other conditions that could reduce the clearance. It's important for utility companies, contractors, and anyone working near utility poles to be aware of the clearance requirements and to take necessary precautions to avoid contact with energized conductors. This can involve using insulated tools, maintaining a safe distance, and de-energizing equipment when possible. Furthermore, public awareness plays a vital role in promoting safety around utility lines. Educating the public about the dangers of approaching or touching down power lines, flying kites or drones near utility poles, and planting trees too close to overhead conductors can help prevent accidents and injuries. The 6-foot minimum clearance is a fundamental safety requirement, but it's just one aspect of a comprehensive approach to electrical safety. It's essential to understand the underlying principles, follow established guidelines, and exercise caution when working near utility lines. The purpose of maintaining a minimum clearance of 6 feet between secondary conductors and communication lines is multifaceted, with safety being the paramount concern. Firstly, preventing electrical hazards is crucial. Insufficient clearance can lead to arcing, where electricity jumps across a gap, creating a dangerous and potentially lethal situation. This arcing can ignite flammable materials, cause equipment damage, and disrupt power supply. Secondly, ensuring worker safety is essential. Line workers and communication technicians need a safe working environment to perform their duties effectively. Adequate clearance allows them to access and maintain equipment without the risk of accidental contact with energized conductors. This reduces the likelihood of electrical shock, burns, and other injuries. Thirdly, maintaining system reliability is important. Contact between power lines and communication lines can cause short circuits, equipment failures, and service interruptions. By maintaining proper clearance, the risk of these disruptions is minimized, ensuring a more reliable and consistent service for customers. Fourthly, complying with regulations is necessary. The National Electrical Safety Code, or NESC, and other relevant standards mandate specific clearance distances to protect public safety and prevent accidents. Adhering to these regulations is a legal requirement for utility companies and other organizations involved in the installation and maintenance of utility lines. Fifthly, mitigating environmental factors is vital. Wind, ice, temperature changes, and other environmental factors can cause conductors to sag, sway, or move. Adequate clearance accounts for these movements, ensuring that the lines remain safely separated under various conditions. To achieve and maintain the required 6-foot clearance, several engineering and construction practices are employed. Firstly, proper pole height selection is crucial. Utility poles must be tall enough to provide the necessary vertical clearance between conductors and the ground, as well as between different sets of conductors. The height of the pole is determined based on factors such as the voltage of the conductors, the span length between poles, and the terrain. Secondly, conductor sag calculations are performed. The sag of a conductor is the amount it droops between two support points. Engineers must calculate the sag accurately to ensure that the minimum clearance is maintained at the lowest point of the conductor. These calculations take into account factors such as conductor weight, tension, temperature, and wind loading. Thirdly, conductor spacing is carefully considered. The horizontal and vertical spacing between conductors on a pole is designed to provide adequate clearance and prevent accidental contact. This spacing is determined based on the voltage of the conductors, the type of insulators used, and the potential for conductor movement. Fourthly, guying and anchoring are used. Guy wires and anchors are used to provide additional support to utility poles, particularly at corners, dead ends, and locations where the soil is unstable. These measures help to prevent the poles from leaning or falling over, which could reduce the clearance between conductors. Fifthly, regular inspections and maintenance are conducted. Utility companies conduct regular inspections of their overhead lines to identify and address any potential clearance issues. This includes checking for sagging conductors, leaning poles, damaged insulators, and trees that are growing too close to the lines. Maintenance crews perform necessary repairs and replacements to ensure that the lines remain in good condition and that the required clearances are maintained. Furthermore, vegetation management is an important aspect of maintaining clearance. Trees and other vegetation that grow too close to overhead lines can pose a significant hazard. Contact between trees and conductors can cause power outages, fires, and electrical shocks. Utility companies typically have vegetation management programs in place to trim or remove trees that could interfere with their lines. This involves regularly inspecting the vegetation along the right-of-way and pruning or removing trees as needed. In addition to these technical measures, training and education play a vital role in promoting safety around utility lines. Line workers, communication technicians, and other personnel who work near overhead lines receive extensive training on safe work practices, hazard identification, and emergency procedures. This training includes instruction on how to properly use insulated tools, maintain safe distances, and energize equipment when necessary. Public awareness campaigns also help to educate the public about the dangers of overhead lines and the importance of maintaining a safe distance. These campaigns may include television and radio advertisements, brochures, websites, and community outreach programs. By raising awareness of the hazards, these campaigns can help to prevent accidents and injuries. The consequences of not maintaining the required 6-foot clearance can be severe. Contact between power lines and communication lines can result in electrical shock, burns, fires, and equipment damage. In some cases, contact can even be fatal. In addition to the immediate dangers, there can also be long-term consequences such as power outages, service interruptions, and legal liabilities. Utility companies that fail to maintain proper clearance can be held liable for any damages or injuries that result from their negligence. Therefore, it is essential to prioritize safety and take all necessary precautions to ensure that the required clearances are maintained. The specific requirements for clearance between secondary conductors and communication lines may vary depending on local regulations and the specific conditions of the installation. It is always best to consult with qualified electrical engineers and local authorities to ensure that all applicable codes and standards are met. While the 6-foot minimum clearance is a general guideline, there may be situations where greater clearance is required. For example, if the secondary conductors carry a higher voltage, the required clearance may be increased to provide additional protection against arcing. Similarly, if the communication lines are carrying sensitive data or equipment, additional separation may be necessary to prevent interference or damage from the electrical field. In some cases, it may be necessary to install physical barriers or other protective measures to ensure that the required clearances are maintained. These barriers can help to prevent accidental contact between the power lines and communication lines. They can also provide additional protection against environmental factors such as wind and ice. Overall, maintaining the required 6-foot clearance between secondary conductors and communication lines is a critical safety measure that helps to protect the public, utility workers, and the integrity of the electrical and communication systems. By following established guidelines, implementing proper engineering practices, and promoting public awareness, it is possible to minimize the risks associated with overhead lines and ensure a safe and reliable power supply.